Hi, my name is Rivera. I'm the Director of Scientific Outreach here at Meter Group. And today we are going to talk about soil moisture release curves. And we're going to focus on understanding the fundamentals behind the measurements. And so one of the first things I always like to ask is, well, what is a soil moisture release curve? And I think when we get that question and think about that, really we need to think about a couple things. And what I would like to start with is really trying to understand the properties that we're trying to look at. And I use this example often where we're talking about extensive versus intensive properties. And it's important to understand that there are two variables necessary to describe the state of matter or energy in the environment. This is true in many different cases. You need to understand the extensive variable, which describes the extent or the amount of matter or energy that is there. And then you have the intensive variable, which describes the intensity or the quality of matter or energy. And I think a good example that a lot of us can understand is temperature versus heat content. So temperature is the intensive variable. That's what we actually feel in the environment. And the heat content is the actual amount of heat that is there in the environment. And that can change depending on different properties about the material and doesn't always tell us a lot about how we're actually going to feel in the environment. And we see the same thing when it comes to water content versus water potential. So to really focus on soil and what we're trying to understand there, we'll first focus on water content, which we said water content is the extensive variable, which tells us the amount of water in the environment. Here you can see an example of how we measure volumetric water content, where we're looking at the ratio of pore spaces that are filled with water versus filled with air. And so you can see some examples of soils with lower and higher water contents here. So that's our extensive variable. It tells us how much water is there. Now we're going to focus on this intensive variable, which is our water potential or our matric potential, often what we refer to, which matric potential is the sum of the matric forces that bind water to the soil. So typically there's adhesive and cohesive forces that are doing that binding. Sometimes we have osmotic and gravitational forces that are also playing a role there, and we'll dive a little bit deeper into that. So as the water content decreases, the energy state of that water actually decreases, it gets lower due to the binding of the water with the soil surface. You can see an example of what that looks like here. And because of that binding, that water actually becomes, one, less accessible to the plants, but also as that matrix potential goes down, if there's an area near there that has a higher matrix potential, the water is going to flow towards that area of low matrix potential, because everything always wants to be in equilibrium. Ultimately, that's the goal. And that's kind of what drives some of these forces, is trying to reach equilibrium. To dive a little bit deeper into the things that we need to understand about soil moisture release curves, we really want to understand the factors that can change the soil moisture release curve. And first, we'll focus on the components of water potential. So when we talk about water potential, we're talking about total water potential, which is the sum of all of these things. It's the sum of the matric potential, which is again, like we talked about, the adsorption to surfaces, the gravitational potential, which is primarily due to a position within a gravitational field and the energy that we need to overcome that. The osmotic potential, which is governed by the solutes within the water. And then the pressure potential, which typically we normally only see in saturated conditions. It's just that hydrostatic or pneumatic pressure from the actual size of the head of the column of water above it. Primarily, we focus on matrix potential because it is the main governing factor in most conditions. In some cases, we do have to worry about osmotic potential in really saline environments, but typically that can be negligible. Another key important part to understand about moisture release curves is hysteresis. And hysteresis can really complicate things, and oftentimes we may ignore it when we're measuring moisture release curves. But hysteresis is a physical force that actually changes as we're going through different wetting and drying cycles. So here you see an example of several scanning curves where you may start at saturation and then you dry the soil back down. As it wets back up, it typically never doesn't reach that full saturation point. And if we were to start drying again, then we wind up on a different curve. And so we call that these scanning curves. And so that can really complicate things when we're trying to understand soil moisture release curves. Oftentimes, we typically just focus on a desorption curve, and sometimes we may focus on a true adsorption curve as well. When we're talking about soil moisture release curves, oftentimes one of our goals is really we just want to identify what our water holding capacity is, right? And the reason that's important, and you can see an example of that here, is the water holding capacity can change with soil type. And so when we're talking about water holding capacity, we're typically talking about the upper end of that capacity, which is field capacity, which can be -10 or -33 kPa, depending on the soil. And then that lower end, which is the permanent wilting point. And so you can see here an example of that with 3 different soil types. And you can see how the available water shifts with these different soil types. So you can see with the sandy soil, there's less available water in that range than there is with the fine sandy loam, and even more so the silt loam. The silt loam has a lot more plant available water in that range than any of the other soils. So this is a factor that can change quite a bit with soil type. There are other things as well that can impact what that looks like, including capillary barriers in the soil and depth of groundwater. That can actually change what the water holding capacity of the soil actually looks like. But oftentimes we don't measure those when we're trying to govern or define what our water holding capacity is. So I've gone over a few basic fundamentals of matrix potential and water content and what makes up the soil moisture release curve. In our next video, I'm going to talk about the tools behind making the measurements.